So first of all, I would like to thank you very much, Joseph, and and really all the KMEA Engineering College for inviting me. Let's start. We are going to talk about blockchain. So, how blockchain technology could change your work is actually pretty a pretty title, but it's hard to answer this question because, first of all, I think maybe it's better to have at least an idea of what a blockchain is. Because when first I heard the term blockchain, I was really confused. Like, what is it? How does it work? How can it be secure? Because it is always said that blockchains are intrinsically secure, are secure by design. But what does it mean? It's actually really complicated to understand. And so maybe when you first approach them, it's easy to skip that part and just trust the words of others that say that, yes, they are secure. Trust me, they are secure. But why should I trust someone else that says that blockchain technology is secure? Well, let's try to have at least a bit of grasping of what makes technology like blockchains secure by design. So what is a blockchain? Does someone of you maybe know already what a blockchain is, or have an idea of what a blockchain is?
It's a collection of networks.
No, sorry.
It is a collection of networks are interconnected. Something transactions are all transactions are signed by each individuals. Something like that.
Yes, yes. It's a good description. It's a collection and an interconnection of transaction of data. Let's call them, or some kind of data that is interconnected in some way, and also with the use of cryptography, okay, to make them secure and immutable. In fact, let's see what is at least my definition of blockchain. Okay, I've written that a blockchain is a trustless distributed ledger, so a log, a registry of something, on which different people can write things that will be validated, and once validated, they are immutable. And moreover, anything on the blockchain is traceable to the person who wrote it on the first time in the ledger. Kind of. It's kind of traceable to the person, okay? Let's see what does it mean. So, a blockchain is, first of all, distributed technology. So it's a system that is actually a collection of systems, like different computers. I can be a part of a blockchain with my PC. Anyone else in the world can connect to the same network and be a part of the blockchain, giving to the blockchain the power of his PC, of his computer. Okay, so the power and the storage also, because the blockchain needs to be replicated. So it's a collection of data that is replicated among different computers in the world, even geographically different locations, of course, in the whole world. Then I've said that it needs to be validated, and when I say validated, I mean that the information stored on this ledger must be consistent with other previously stored information and should not be possible to alter this information, or at least should not be possible to, and also, sorry, should not be possible to store misleading information. Like if we speak about blockchain, usually we think about cryptocurrency. So, the blockchain, no, the blockchain must also be immutable. What does it mean? That after that an user has inserted some kind of data into the blockchain, so it has added a block maybe, or a line inside a block, let's call it like this, it must be accepted and validated, and then that's it. Then the block is secured forever in that state and cannot be modified. Or, well, of course, it's a bunch of zeros and one in a computer, so it can always be modified physically. But if someone modifies it, we should be able to quickly understand that it has been modified and revert the action, or not accept the modification into the system. Okay, that means that the system is immutable. So we have this scheme in which we want Alice to be able to sign her message, and with the help of the secret key, Alice can pass the message with the secret key inside a signature function and produce a signature. Okay, that is message. Bob receives the message and wants to know if that message is indeed what Alice wanted to send him. Okay, so he takes the public key of Alice, which should be in a place, I don't know, like a public server, a public, or maybe Alice sent it to Bob earlier. And then Bob takes the signature and the public key. It passes it through the same signature function, but it doesn't matter actually, but it's the same. And it produces the message. So it's a reversible process. And then Bob just wants to know that the message he received is the same that Alice sent, the sign, sorry. If that's the case, the message is considered valid. If the message that Bob received is different, the message is considered invalid. Now, how can this help us in securing the blockchain? It's pretty clear. Alice, if Alice wants to add something on the blockchain, she must add the message plus X signature on the blockchain. So like this is a representation of the blocks on the blockchains. Alice just added the message plus its signature produced by its secret key. And her public key must be publicly accessible by any user of the blockchain, of course, to be able to validate the message and the signature. Okay, that's a simple digital signature, of course, but it works like this even in real life. Then we have the concept of cryptographic hash. So it's another thing that, of course, comes from cryptography. And what is a cryptographic hash function? It's something that takes arbitrary data, like anything actually, photo, images, text, documents, anything. And it creates a fingerprint that is also called a message digest or simply the hash of the data. Okay. I don't know if you already know it, but that's how it works. And just like our fingerprints, human fingerprints, are used to identify us, like because there's almost impossible to find two people with the same fingerprints, maybe twins, I think, but that's a rare occasion. Or maybe, but so it's the same for a cryptographic hash, in the sense that if you have a message and you produce its digest, which is always the same, so the same message will always produce the same digest, okay? And you want to find another message, or maybe you want to forge another message that has the same digest. It's pretty impossible. It's likely improbable to be able to find such a message if you have just to try. You do not have any better option than to try random data until you get the digest you want, which is unfortunate. Well, for us, it's really important that it's like this, but if we are attackers of some kind, it slows us down really, really, really much. So how it is used? No? Well, how it is used? You see, if I pass a message through the cryptographic hash, it gives me some kind of numbers, gibberish number. If I change even slightly my message, even just with punctuation mark, the hash is completely different. And so it is a very strong way to like make a digest of something, make something that represents in some way my data, even if it's just really, really small, because now I've chosen a message that is really simple, so the digest is maybe more, is bigger than the message itself. But if you have a really big photo or video also, like even gigabytes of things, you pass it through the hash function, you get always 256 bits of data that represents in some way the message. So it's really handy. How do we use it in blockchain? It's used multiple times. In first place, it is used to create the actual blockchain. So, for example, every block has the hash of itself and of the previous one. And as you see, you can kind of think of these two hashes being present in the previous and the next block as a link between the two blocks. Okay, so the chain is just a chain because blocks have included the hash of the previous blocks. So you see the pink one is the hash of the previous block in the second block, and it refers to the previous block. And the chain is made like this. And of course, you chain many, many blocks together like this. And when you have many, many blocks chained like this, the hash also render the order of the blocks immutable, because if you try to swap two blocks, like I swapped the last two blocks, like this, of course, the hashes doesn't match anymore, because the purple one is now referred by the last, but it's not matching with the green one. So You cannot swap blocks inside the blockchain without knowing. So if I receive a blockchain that is in this state, I just refuse it. It's not valid. It's not a blockchain. Or maybe I can just reorder the blocks, but that's another matter, of course. And what's most important, if I want to make a modification to a block inside the chain, like this, of course, the hash of this block, if I modify it, will change, will not remain the same. And changing this hash breaks the blockchain. You see, the blocks that comes after it are no longer referring to the right hash. So the blockchain is broken. And these two things make the blockchain completely mutable, because if someone tries to reorder the blocks or modify the content of a block, the blockchain is no longer valid. And this is really powerful. This is what where it comes the security, the intrinsic security of the blockchain. No one can add anything without its signature, so you always know who made something. At least you know the public key of who made something. Maybe the public key is not associated with a real identity, but you know the public key associated to something. In Bitcoin, the public key is actually kind of the address of your transactions, okay? And you also have this property, so that the blockchain is immutable. Now, I don't know how much time I have left, actually, but maybe I should skip this part. So, where was I? So adding a block to the blockchain is actually, it depends on the blockchain we are talking about, okay? It's really diverse across different blockchains, but here I made an example with the Bitcoin blockchain and the proof of work, which is the algorithm, the protocol that it uses. And it relies on properties of the hash function, so the same that we already seen. And you just have to guess a number for the hash function of the blocks. So it's really a guessing game for blockchains. You have to do a lot of random work to just guess the number that will make the hash start with some number of zeros, not 3, maybe 60, but it gives the idea, okay? And then you add the blocks inside the blockchain if you win. And this process is called mining in Bitcoin. And I will skip now this part because I don't think I have much time left. Let's talk about what blockchains are used for today, because maybe it's also interesting to know. Okay, blockchains are secure. Blockchains are intrinsically secure, and they are, moreover, they are secure even if they are public. That's it something, because right now maybe someone think that to make something secure it must be hidden to the public, but blockchains are actually public. Everyone can see what's going on, and still they are secure. So it's a pretty revolutionary thing. And of course, today blockchains are used mainly for the cryptocurrencies, okay? So like Bitcoins, but we have also really great other number of cryptocurrencies, okay, and that uses many different techniques, not always proof of work, because the Bitcoin proof of work is what makes Bitcoin really energy hungry. Okay, Bitcoins consume the same amount of energy of like Sweden or Malaysia or something like that. So it's pretty not environmental friendly. Ethereum, for example, uses the same proof of work that Bitcoin, but is shifting to another thing that is really, really faster and not so energy hungry. So, and today's we have these. We have blockchains that we have enterprises that offer blockchains to transfer money across continents, that offers of course trade in the stock market for I don't know, assets in the stock market or derivative products. Then you have also in the Ethereum blockchain, we have smart contracts, which are really handy features. It's like you are storing on the blockchain a program. It's like a self-executing contracts, which is actually a program, a computer program, which is stored on the blockchain and which is automatically executed under some condition that is set in the contract itself. And it can be executed on the blockchain itself, like, of course, on the computers that make the blockchains. So if I am part of the blockchain, the contract may be executed on my computer, but it's executed in the safe environment of the blockchain. So, for example, I could say that at some time in the future, I want to give some amount of money to another user of the blockchain if something happens, like, I don't know, in the stock market or in the anything in the world that can be monitored through blockchain and through internet. Maybe it's not like that, but maybe it will be like that. Then we have, especially in the last year, we have seen the growth of non-fungible tokens, which are something like how do you call it? An ownership certificate of something. Okay, non-fungible token, just certificate that you own something, even if it not in a sense it is not ownable, like a digital image. A digital image can be copied many times, so it is not ownable, like I cannot prevent it to be copied over and over and over. But still, if I create a non-fungible token for it, there can be only one non-fungible token. So maybe the image will be replicated hundreds of times, but if I am I don't know, a collection enthusiast and I want to own that image, even if it's in thousands of computers around the world, I can say that I own that photo because I own the non-fungible tokens referring to that photo. And we have IBM also here, which is one of the biggest enterprise that is investing in blockchains. And tomorrow, I don't know, tomorrow maybe blockchains will be used in the logistic industry. And so now we saw that blockchains can be something that you want to work with. So, and you have seen we have a lot of enterprises which uses blockchains. So if you would like to work with some of these companies in Europe or anywhere else, actually, you, of course, you need your skills to be able to enter in those companies and begin your career, maybe. Okay, so Linda Lucina will tell
Hi.
you how you can achieve such a difficult task.